All right, so my class right now is entering transformations of functions. We're trying to figure out what happens when we do stuff, essentially, to a function, f of x, g of x, h of x, any function, right? And before we do that, I think that there's a lot of students that don't have the confidence. We need to be gaining some confidence around really graphing and figuring out what any function looks like, much less trying to transform it, right? So let's just start with something simple, something that used to trip me up a little bit. F of x equals the absolute value of x. That's what these two little bars mean. And I just wanted to give you some strategies for what you should do. If you're encountering a function, you're like, ah, crap, I can't remember what that looks like. Well, what should you do? And what I do is I start, and I asked a student this, and they actually gave me the right answer, is just start plugging in numbers to see what you get. And I start creating a table of values. So let's connect that. Let's connect that idea. Hopefully this isn't too separated in your mind already, but you've probably looked at a table of values, and I'm not sure how much you've really connected it to an actual graph. And I just think that's a really important skill. And you can do this with any graph, right? So it doesn't matter if it's something that you know what it looks like, x squared, sorry about that squiggle, or if it's the absolute value of x, or if it's something really messy. Let's just start off with an easy example. So f of x equals absolute value of x. Well, what happens when x is 0, let's say? And I'm putting that here. I'm going to leave some space for some other numbers. Well, f of 0, right, if I plugged in x equals 0, I get 0 back. All right, so that's my first point on the graph. I already have 1 point on the graph, and I can keep going. Remember, I got to label these axes. I'm going to label the scale. That's going to be important. Let's just keep on trucking here. Sorry about the delay. That's -3. This is going to be -1, -2. All right, so what happens when x equals +1? Well, when I plug in 1, I get absolute value of 1 is 1, right? So now I have the point 1, 1 on the graph. Right? You could list these as ordered pairs on here, right? So I've got 1, 1, and I could keep going. When x is 2, I get 2, right? So 2, 2, and then what happens when x is negative, right? So -1. Well, absolute value of -1 is really just saying how far away from 0 is -1, and so the answer here is +1. So at x equals -1, I get an output of +1, and something similar happens here. When x is -2, I get 2. And so that's that point. And we could continue this process. You could see that this is what the graph looks like. Let's see if I can draw that accurately. It's kind of hard with the camera part of it. But that's what the absolute value of x looks like. All right. So you could do this with anyone. If it was x squared minus 3x plus 7 and you didn't have a graphing calculator and you want to know, you could make a table of values and plug in numbers. So when we learned function notation, and we learned how to plug in numbers and replace the x with whatever number's in there, that was a valuable skill that you can now use to create a table of values for yourself and figure out what it equals, right? So let's do that again, all right? Let's do that again, except now let's change what this equals. So now let's talk about a function h of x that's similar to the absolute value of x, but I'm going to change it a little bit. I'm going to say h of x equals the absolute value of x minus 1, and then plus 3, let's say plus 3, all right? So again, oh no, I want to test, I don't know what's going on. Well, let's just go back to the table of values. Let's look at the table of values so that we can make a little graph of this. You don't have to remember everything about transformations of functions right now. You just need to know how to make a table of values. Can you plug in numbers? It's going to take you a little bit longer, and you wouldn't want to have to do this every time, but maybe this is your starting point. Maybe this is a backup plan for you, all right? So we've got h of x equals x, or the absolute value of x minus 1 plus 3. All right, so what happens when x is 0? Let's just start with 0. So when x is 0, let's plug in 0. So I can write a little note over here. H of 0 is going to be the absolute value of 0 minus 1 plus 3, right? So 0 minus 1, that's going to be -1. The absolute value of -1 is +1. So +1 plus 3, that's 4, right? So when I have x is 0, I get an output of 4. And again, I need my scale here. I'm going to count by 1s for every one of these lines I see. 4. So when x is 0, I get an output of 4. I messed that up here. When x is 0, I get an output of 4. Yeah. That's right. So 0, 4 is on the graph. Okay, so now I want to look at what happens when x is 1. So when x is 1, I plug in 1 into my original. 1 minus 1 is 0 plus 3, and I get positive 3. All right, so 1 is 3. And I'm not worried about, oh, is it right yet? I'm not sure if it's going to look the same. I don't know what's going on, so I'm going to just keep going. So what happens when x is 2? 2 minus 1 is 1. The absolute value of 1 is 1, plus 3 is 4 again. So at 2, I get an output of 4. At this point, I can kind of see, oh, I think I know where this is going. Let's try some negative numbers. Negative 1 minus 1 is negative 2. The absolute value of negative 2 is 2. 2 plus 3 is 5. So I'm going to get an output of 5, and that would be, I guess I'd have to extend this graph, wouldn't I? Let me extend this graph a little bit here. Just to negative 5 at least. So then at negative 1, I get an output of 5. Or negative 5. Yeah, positive 5, sorry. Stumbling over words over here. So the same thing's going to happen here at negative 2. Negative 2 minus 1. Negative 2 minus 1, that's a negative 3. The absolute value of negative 3 is 3. 3 plus 3 is 6, right? You can kind of see where this is going. It's going to be 3. The positive 3 here, that's going to be 5, right? So it looks like we've got a little graph going here. And this looks very similar to what I had originally. And the reason I'm doing this is transformations of functions. So I started off in my first example with the absolute value of x. Then I do the absolute value of x minus 1 plus 3. And I just kind of look, let's just start off by observing what happened. Here, looks like this, the 0, 0 was on the graph, and that point looks like it got shifted over to here. So it got shifted to the right. So this graph shifts right 1 and up how many? 3, right? Shifts right 1 and up 3. All right. So why did that happen? Why did that happen? Well, I mean, we can look at the table of values. Maybe the table of values just kind of told you why. But what we should probably do is let's look at a digital version of this and look at what happens when we add the value inside the x for any single one. And then let's make some general observations about that. In other words, what we want to do is we want to figure out what happens when we take f of x and we add an arbitrary number a inside here, or if we add a number here, an arbitrary a or b. And we're going to look at that inside Desmos to figure that out. All right, so we're going to work with transformations of functions still, and we're going to work with the same example that we just had. So if we had f of x equals the absolute value of x, we have to type in this. Turns out that's the same as what you would type in or use in your graphing calculator. There's a function for that. So the absolute value of x looks like this. We already talked about what the table of values would look like. And what I would like to do is figure out what happens if we're going to move this around. So if we wanted to shift this up, left, right, if we wanted to shrink it, what would we do to it? So what we're going to do is explore that phenomenon. So we have f of x plus any arbitrary a. What happens to the graph, right? What happens? So I'm going to add this slider and see what happens. All right, so let's pause there. F of x plus a. So if I've got this number, an arbitrary number inside the parentheses, and it stopped at, what is that, 5.6, let's say. What happened to this graph? So this purple graph or blue graph, maybe I'm colorblind, is shifted. So it originally started here. This was 0, 0. Now it's shifted over here to negative 5.60, which is the exact opposite of this number, right? Negative 5.6, not positive. So that's kind of counterintuitive, and that's kind of why I'm demonstrating this. If you are shifting it left and right, first of all, you have to add or subtract a number that's inside here, inside the parentheses here in f of x. So counterintuitive, you got to kind of memorize that part of it. You can look at a table of values and see why. There's a great Khan Academy video that explains it. But that's the exact opposite of what you might expect. So if you want to shift something to the left, you have to add a number to it, a positive number, right? So let's see what happens when we need to shift it up or down. So let's add this slider here, and let's just animate that point, or animate that value, I should say. So when b is 5.68, it looks like the graph has shifted up, which is intuitive, that's very helpful. So the shifts up and down are really intuitive. You can tell, all right, if I want to shift it down 10, I just subtract 10 from the entire function, right? So if I just had, oops, f of x minus 10, I don't even need these sliders anymore. This graph is just shifted down 10. The outputs are all shifted down. Remember, the outputs are the y values. So the y values are just shifted straight down, right? If I want to shift it down 5, you just minus 5 from the whole thing. Shifting it left and right is different. If I want to shift it to the right 7.3, I can't just 7.3, that would be wrong, right? That's shifted to the left. If I want to shift it to the right, I have to subtract. So it's counterintuitive, something you want to memorize. The left to right stuff is going to be a little bit different for you. It's going to be backwards. The up-down stuff is going to be the exact same. And that actually works for any function. It's not just the absolute value function. If you did this with x squared, it would be the same thing. So you could do f of x. If I want to shift this to the right 4, I have to subtract 4. See how that moves it to the right? Let me change the color of it so you can see. This red one is shifted to the right 4. Okay. Now if I want to shift it down 7, I can subtract 7. That's very intuitive. And it works with x cubed. Oops. Third power, it works with any function at all. And you can see how that works. All right, so just to wrap this concept up into a nice little package here, we've got a horizontal shift and a vertical shift. It's a horizontal shift if we're adding a number inside here. And remember, if a, it's counterintuitive. If we want to go right, we need a to be negative. We need a to be less than 0. And if we want to shift to the left, we need a to be positive. So this part's counterintuitive, okay? And then if we want to shift the graph up or down, the vertical shift, if we want to go up, that is intuitive. A can be positive. If we want to go down, A should be negative. Something you definitely want to memorize, but keep in mind you can use a table of values to kind of figure that out if you forget temporarily.